everybody, this is Rudra Pradhan here and welcome you all to BMD course, and we are still in inferential analytics, and this is the third lecture of this particular series, and we like to continue these lectures corresponding to previous class discussions. So, the idea behind this particular lecture is like this. So, we have a problem, and corresponding to a problems we have to design a particular hypothesis which we need to be tested. So, the idea is that it is a kind of observations or the kind of thought process through which something need to be tested, and the usual testing structure is like that the comment about the populations, that is derived from the problem, and then with the help of data or samples. So, we have to take a decisions and that too corresponding to the population structures. So, that means typically the idea is to check how sample statistic is deviating from the populations parameters. So, now there are three different ways we have to discuss this particular process. So, sampling distribution and populations. So, population is there. So, we have to draw the samples and check whether sample statistic converts to population, and if not, then the sampling can be created as sampling distribution, and then we have to check whether sampling distribution will convert to population. So, that means altogether there are two different ways we can do the processing, but by the way most of the times the game will be sample to populations. So, in between the particular structure is called as sampling distribution. So, what will you do? So, we will check actually the procedure through which you have to draw the samples, and then we have to check the kind of sample statistic corresponding to the population parameter. So, now in the last class which we have discussed various test statistic structure and the empirical testing procedures. In the testing kind of environment, we have altogether 4 different test statistic through which we will do this particular investigation process. These test statistic are Z statistic, T statistic, chi-square statistics, and then F distributions. And in the last lectures we have discussed couple of problems through Z distributions. So, that means the idea is that you have again comment on the populations, then on the basis of population parameters. So, we have a sample statistics, then compare contrast, and we will get some kind of inference on the basis of population specification or the problem kind of design. So, now in the Z distributions, in the particular Z test, so we have the structure of population parameters. So, what will we do? So, we have to just connect with the sample statistic with the population. That means typically population parameters means mu and standard deviations are given, and once these things are reported. So, the structure will be tested accordingly, and on the contrary sometimes your mu and standard deviations will not be available, then we will do the kind of experiment, again similar kind of comment to the population parameters. So, now in the discussion process which we have already discussed in the last lecture, the procedure is like this. So, it is the starting is the comment about the population parameters. So, in this particular case mu equal to 4.30, and the alternative hypothesis will be mu less than equal to 4.30. So, that means typically we are targeting here one tail test, and we can also go for two tail test by putting mu not equal to 4.30, or you can go for right side of the another one tail. So, specifying mu greater than 4.30. So, that means there are 3 different ways we can do this particular testing. And by the way, in the testing procedures we have actually 2 different ways to get the inference and taking the kind of management decision. In the first process, So, what will you do on the basis of population information and sample statistics, you have to find out sample statistic test statistic value, then the test statistic value will be compared with the test critical value, and if the test statistic value will be lower lesser to lower bound and greater to higher bound upper bound, that is upper bound. So, then you are rejecting the true null hypothesis. If not, then it will be in the accepted zones, and in that case you are not in a position to reject the true null hypothesis. This is the first approach. So, in the first approach it is the test statistic through which we have to compare with critical value, and then you have to take a decision. On the other sides, so once you find out the test statistic corresponding to test statistic, you find out what is the probability value, and then you have to compare with the probability value which you have previously specified for taking the management decisions. Now, if that particular probability value is be lesser than to the particular specific value, then you are in a position to reject the true null hypothesis, otherwise you have to accept the alternative hypothesis. So, now in the last lectures we have discussed the same problem through test statistic approach. So, where you have to calculate the test statistic, then compare with the critical value and take the decision whether to accept the null hypothesis and to reject the null hypothesis. In this case here, we are applying the p value approach, then we are taking this same kind of decisions in the same problems, but here the structure is the p value approach rather than comparing the test statistic with the critical value. So, now having similar kind of framework problem design. So, mu equal to 4.30 and against mu less than 4.3. So, now so your alpha fixation will be 5%, that is 0.05, and as a result your rejected zone will be this side and remaining 95% will be accepted zone. And so, in the p value approach, if the particular p value corresponding to test statistics, sample test statistics is less than to alpha, so which is nothing but actually fixed here, then we are in a position to reject the true null hypothesis, otherwise you have to accept the alternative hypothesis. That means, we are not in a position to reject the null hypothesis. So, now corresponding to this problem, so assuming that x bar equal to 4.1.56, which can be derived from the sample information, and then this is the population parameter mu 4.30, which is actually specified on the basis of problem formulation, and then standard deviation also given to you. So, that is 0.574, and then sample size is specified here 32. Then on the basis of the z statistics, so we will calculate the z value is coming minus 1.42, right. So, now what will you do actually? So, you go to the z tables, then you check what is the probability value corresponding to z equal to minus 1.42. So, that means typically you have to see the z value z tables, and that to z value for 1.42, and then check what is the particular probability. So, now if you go to the z tables, then you will find the probability value is coming actually 0.0778, but our actually value fixed at actually alpha equal to 0.05. So, now here actually this p is more than 0.05. So, that means technically here it is coming around 0.08, but actually the alpha value which you have fixed is equal to 0.05. So, as a result, so the p is coming this side only. So, that is the accepted zone. So, as a result, our declaration will be that we are not in a position to reject the true null hypothesis. That means, so the mu which you have given 4.30 is a question mark, right, is a question mark. So, accordingly, so the decision is that it is the same structure. So, in the earlier case, so we are actually comparing with the z value, that is minus 1.42 with the critical value, so which is nothing but 1.96. Now, here we are comparing actually p value corresponding to minus 1.42, then comparing with the alpha value, and in both the cases we are not in a position to reject the true null hypothesis. So, that is how, so that is the process through which you have to take the decision, and then you have to come to the kind of inference and the kind of solutions. The same things here. So, it is the actually here alpha 5% and then corresponding to the problems. So, z critical is coming minus 1.645 and as a result here. So, this is actually declared as a accept just a minute. So, this is declared as a rejected zones and by default this is declared as accepted zones, and then corresponding to the previous discussions. So, the same structure you have to follow and then you have to take the decisions. Okay. So, the decision will be like this. So, now you have to calculate the z value, again it is coming minus 1.42 and since minus 1.42 is coming greater than equal to minus 1.645. So, you are not in a position to reject the true null hypothesis. So, that means, so in the p value approach, so the conclusion is in the acceptance of null hypothesis. That means, you are not in a position to reject the null hypothesis. So, here also in the case of test statistics, so that is actually, so the z value is coming like this and the critical value is coming like this. So, as a result, so the z calculated is above than the z critical. So, that means, minus 1.645 is actually coming other side. So, as a result, you are not in a position to reject the null hypothesis. So, that means, the idea behind these two approaches are same, and whatever conclusion you are getting in the first sites, the same conclusion you are getting also in the second approach. That means, whether you apply the p value approach or kind of test statistic approach. So, the conclusion remains same. So, but we have two different alternatives through which we have to actually investigate the problem, get the inference and then take the management decision as per the problem requirement. Okay. So, this is how the kind of structure, and similarly, so what we have already discussed that once you have specified the concept a population parameter, then corresponding to the kind of alpha structures and the kind of choice of the test statistics, you can also find out the kind of lower bound and upper bound through which actually your sample statistic can be represented. So, in this case, so the upper bound will be mu plus z s by root n. So, that is actually 4.133, but actually the mean value is coming 4.30 and here actually one particular critical value will be 4.133. Similarly, you can go for actually other sites. So, the other side will be the kind of different structures that means, it is actually two different sides, it is a mu plus minus. So, the plus side will go to the right side, that is the upper bound, and the minus mu minus z sigma by root n will be coming in the left side. So, by as a result you will find a kind of confidence interval. Okay. So, we have a more discussion on confidence interval after this lecture, but in the meantime, so here also we can actually report the same things, and then okay. So, this is how the clear cut decision making process now, and since x bar is coming actually 4.133 and that too is actually comparing with 4.30. So, as a result you are not in a position to not in a position to take a decision, and so in this case typically x bar is coming 4.133. So, that means, actually it is actually lesser to this critical value. So, as a result you have to reject the null hypothesis, and in the counterpart, if x bar is coming greater than to 4.133, you are not in a position to reject the in null hypothesis. So, in this typical case x bar is coming 4.156 and which is greater than to 4.133. So, that as a result you are not in a position to reject the null hypothesis. So, that means it's actually kind of a decision making process, and the process is very simple actually, corresponding to kind of population parameter and choice of the test statistic and the kind of alpha fixations. So, you will get the critical value, and once you get the critical value, then the sample statistics positions will specify whether to accept the null hypothesis and alternative hypothesis. Then accordingly you get the inference, and on the basis of this inference we have to take the management decisions, right. So, then SEM structure here, and this is another way to actually specify the kind of structure, and in the the same things we can test through a spreadsheet, Excel spreadsheet, and in the Excel spreadsheet. So, what we will have here? So, this is actually the kind of test structure which you like to test, and here mu is actually 4.3 and corresponding to mu equal to 4.3, alternative hypothesis will be mu less than to 4.3, and these are all actually sample information. So, we have altogether 32 samples, n equal to 32, starting with 3 and ending with 5. So, alpha we are fixing here 0.05, that means 5%. You can actually change the alpha value, you can go to 1%, you can go to 10%. So, accordingly you will find different kind of critical value, and if your alpha will change, then critical value will change and the decision will also accordingly change. But if your sample size will be very high, then the change of alpha may not drastically affect your decision making process. So, with the basis of these samples we have to calculate the means, which is our requirement. So, that means technically the formula is z equal to x bar minus mu by s by root n. So, okay. So, that means technically, so here mu is given, that is actually 4.3, and then rest of the things you have to calculated from this particular sample observations, right. And so, there are 32 observations. So, the sample mean will be a sum of all these observations divided by 32. So, which will be coming actually 4.156, and here the population mean is given actually 4.3. So, that means in this particular problems we are assuming that the average structure will be 4.3, and that is how the comment about the populations, and our investigation process will be that whether the particular mean is correctly specified or there is a need of some kind of change. On the basis of that, so investigation is done, and on the basis of these samples we have got the sample statistics, and then we will come with the help of test statistic we have to compare with the population structure, and then come to the conclusion or inference, and accordingly we will take some kind of management decisions. So, now the standard requirement is to find out the mean. So, from this sample observation you can easily get the mean value. So, this is simply sum of the all observation divided by the sample points. So, that is 32 and it is coming 4.156, and the sample variance will be coming actually. So, that is actually, so the x bar is nothing but summation x I by n, and that is nothing but summation x I by 32, right. And in the case of this one, in the case of standard deviation, so it is nothing but actually a summation x I minus x bar whole square divided by n, and then once you get this variance, so you have to find out the standard error, that is actually nothing but actually s by root n, and once you get the standard error, so then your difference between sample mean minus population mean divided by standard error will give you the z value. So, it will give you the z value. So, now once you get the z value, and corresponding to the z value you have to find out the p value, and since alpha is already fixed here 0.05. So, that means technically, so here the approach is like this. So, you have alpha equal to 0.05. Now, you have to find the sample statistic is showing z equal to minus 1.42. So corresponding to z equal to minus 1.42. So you have to see actually what is the probability value here. So the probability value is coming corresponding to z this much is coming actually 0.078, which is actually overtaking this particular value. So this particular, that means your sample statistic is actually in the accepted zone, and in the same things you can actually conclude in other way. So where you 0.05 you find out corresponding to alpha 0.05, you have to find out the critical value, and this critical value can be compared with the z calculated, that is minus 1.42. So then you have to see the position whether it is in a accepted zone or it is a kind of in a rejected zone. Then on the basis of that you have to take the calls. So whether to reject the null hypothesis or to accept the null hypothesis. Okay. So now accordingly, so you have to move to this structure and see here. So this is actually Excel spreadsheet, and either you calculate separately and report, or else you just enter the data and then you go to this structure. So here actually you just put Excel server command. So it will give you actually how much, obviously the answer will be 32 here, and alpha is fixed here, mean you specify from this end to this end, and that is F4 to H7, and similarly standard deviations F4 to H7, and standard errors is nothing but standard deviation by root ends. So it is coming actually whatever on the basis of sample you will get these ones, and then again you have to find out the z value and compare with the z value with p value, that is on the basis of normal distribution, and then compares and on the basis of these comparisons you will come to the conclusions that whether to accept the null hypothesis or reject the null hypothesis. Okay. This is another kind of problems, and in this problem need to be actually tested through two-tailed test, and here it is a small sample case, and that is on the basis of n equal to 20, because whether it is small sample and large samples. So we have to see actually whether n is coming less than to 30 or greater than to 30. So since n is coming 20, so we will consider that this problem is a small sample case, and these are the sample points. So these are the sample points, and on the basis of these sample points, so you will find out sample means and sample standard variance, and then n count is 20, and then alpha is fixed here 0.05, that is 5%. You can change the alpha value 1%, 10%, 7%, whatever ways you can change. So then your the comparison will also, or your decision will also change accordingly. And again once again I am continuously repeating that when your sample size will be increased towards infinite, then there is a high chance that you are in a position to reject the true null hypothesis, if your problem is very consistent very accurately or exactly specified. And then corresponding to these problems, so what will you do? So these are the reporting, and then what will you do? So let us say mu equal to actually 25, and corresponding to this mu equal to 25. So your calculated okay. So what will you do on the basis of this one? See here, if population parameters are not known, then what will you do? You use this sample informations and represented as population parameter, and on the basis of that again you have to actually compare, and then you have to take the management decision. And in this case, since it is a small sample case and sigma is unknown, so the test statistic which you like to choose to take the management decision is nothing but called as t statistics. So generally z is used actually when sigma is known to you and the sample size is substantially very high, and if not, then best test statistic which you can apply to get the inference is nothing but t statistic. And in this case we are going to use the t statistics, and it is more or less same like z, but everything will be collected from the sample informations, and as a result we are specifying here first population parameters, that is mu equal to 25, and we are going for two-tailed test. As a result alternative hypothesis will be mu not equal to 25. So, then you go to the t tables. So, like Z table we have a t tables corresponding to the degree of freedom and your alpha value. So, you will find a critical value and that critical value will be fixed here again, same like Z test. So, here actually to know this critical value you need two things, alpha indication and the degree of freedom, which is nothing but actually n minus k is the number of variables involved in this process and n is the sample size, and corresponding to this you will find critical value, and if it is two-tailed then it will go to the both the sides by alpha by 2 that is 0.025 and 0.025 as per your earlier discussion. So, this should be the rejected zone, this should be the rejected zone, and this one will be the accepted zones. So, now our idea is actually to using the sample test statistics, you have to see whether test statistic value will be in the accepted zone or rejected zones. Accordingly, we will put comment to the population parameter, and then we will take some kind of management decision. Okay. So, corresponding to this, and we will move like this, and then so in this case with the help of samples we are getting a sample mean is coming actually 2.5. So, let me once again highlight here. Okay. So, 25.51. So, that is actually the kind of sample information, and population figure is already given, and this is actually sample variance, and so this and x bar and s need to be calculated. N is the count, that is the sample size. So, that means everything is there in the particular spreadsheet. So, on the basis of spreadsheet data you have to first calculate sample mean and sample standard deviations, and then you have to find out the t statistics, and t statistic actually more or less same with the z statistics. Only difference is in the case of z mu will be a given or population parameters will be given, and then z can be applied when the sample size will be large, and if not then you will apply the t statistic, but the structure is more or less same so far as calculation is concerned or the testing is concerned. So, as a result, so the t calculated will be 1.04 like z calculation. So, then you have to see whether this t calculated will be in the accepted zones or rejected zones. Then on the basis of t tables where alpha equal to actually 5% and that too under the two-tailed umbrella, and corresponding to the degree of freedom 19. So, your critical value is coming 2.093, and since it is actually coming 1.04. So, by default you have to come to this side, and 1.04 means it is actually coming under the accepted zones, it is coming under accepted zones. So, by default your conclusion or the inference is you are not in a position to reject the true null hypothesis. That means, the statement which you are targeting is correctly specified. Okay. So, now corresponding to this problem, so then you move again, and again this can be actually very easily can be done through Excel spreadsheet, and in the Excel spreadsheet you just specify this particular indication, and these are all sample observations, and a total sample observation is coming 20, and we are specifying alpha equal to 5%, and using these samples you have to find out mean, and then you have to find out the variance, and then you have to calculate the standard error, and on the basis of standard errors and the other requirements you have to calculate the t statistic, which is nothing but actually x bar minus mu by s by root n, and then on the basis of actually t value you can check the probability value, right. So, either way, so this here also you can compare test statistic to critical value, or you can on the basis of test statistic you find out the p value and then compare the p value with the alpha fixations, whether it is a 5% or 1% or 10%, then you take a decision whether to reject the true null hypothesis or accept the true null hypothesis. So, now corresponding to this you will go to the actually Excel spreadsheet and check this is how the kind of structure, and these are the command which you have already discussed, and once you enter the data and then systematically you calculate all these items, and finally you have to check actually whether to accept the kind of things, or you have to reject the kind of things. So, now the comparison can be done accordingly, and this is what actually the kind of okay. And this is what we have already discussed, and then the second problem will be like this, again similar kind of problems. So, here sample size is 23, and then with the help of the sample informations, so you can actually calculate the kind of mean and variance, and then again you apply test statistics to validate whether to accept the null hypothesis or reject the null hypothesis. So, accordingly you can actually take the call to or take the management decisions. Now, corresponding to this data, so we are fixing population parameter for 71, that is mu equal to for 71 for H 0, and the counterpart will be mu greater than 471 for alternative hypothesis. So, that as a result your critical value structure will be like this, since it is actually mu greater than, and as a result your typical critical value zone will be this side only. Okay. So, this is what actually critical value zones. So, it is coming actually minus 1.717, and this is actually obtained in the T tables corresponding to alpha 5% and the degree of freedom 22. So, now so the you check actually what is actually T calculated, then you will check whether the T calculated is coming under the accepted zone or rejected zone, and on the basis of that you have to take the management decisions, right. So, then here is the kind of call, and T is coming actually 1.717, and then on the basis of sample statistics, what we have actually here T equal to coming to 2.84, and 2.84 means it is actually overtaking this critical value 1.717. So, as a result straightforward answer is to reject the true null hypothesis. So, straightforward answer is the rejection of true null hypothesis. So, that means it is actually standard kind of format, and every times so you take the samples and then use the sample test statistics and calculate the kind of test statistic value, and then with the help of alpha indications and the kind of degree of freedom, find out the critical value and check the position of the test statistic whether in the accepted zone or rejected zone, and on the basis of that you have to take the management decision whether to reject the true null hypothesis or accept the true null. So, that means it is actually kind of interesting kind of structure, and most of the management problems used to check randomly corresponding to the kind of change they have to take kind of future with respect to time. For instance, let us say average profit for a particular company is coming something like let us say for $4,000 US, but you have to check actually whether over the time or over the kind of cross sectional unit this particular structure is still valid or not valid. So, with the help of this sampling and sample statistic, you may be in a position to take the call and take the decisions. So, like many different instances you can actually try to apply this particular structure, and then you have to take the management decisions every time means this particular structure, particularly this hypothesis testing and so far as inferential analytics is concerned, it is every time actually to check what is the population structure and whether the population structure is still valid, and some it cannot be actually valid for the long time. So, over the time the population parameter may change, and the change which can be actually specified against on the basis of testing only. If the sample statistic actually not converging, then there is a difference, and if the difference is statistically significant over the time and over the different kind of cross sectional process, then by default the population parameter may be changed, so accordingly the management decision need to be taken. So every times it is a kind of continuous affairs, and then management decision has to be taken as per the kind of the cross check process only. Okay, so this is what the particular structure. Okay. And there is another kind of structure through which actually you can test the investigation, that is called as population proportion, and this can be also applied through Z statistics. And here in this case it is actually similar kind of process. So, this is actually sample proportion, and this is what actually population proportions, and this is nothing but actually probability concept. And since total probability exactly equal to 1, then this is the if the p is the probability of success, and by default q is the probability of failure, which we have already discussed in the kind of distribution and probability distributions. And here Z statistics is the difference between sample proportions minus population proportions, like x bar minus mu. Here actually p estimated minus p, and then it will be adjusted with square root of probability of success with the probability of failure and the sample observations, right. So, then accordingly the same process will be followed, and then management decision can be taken into considerations. So, now the process will be more or less same again. So, you have to put the population indications, and then you have to calculate the sample statistics, and then compare with the critical value. So, the decision again same, so whether to accept the true null hypothesis or reject the true null hypothesis, right. So, in this case it is coming minus 1.645 is the kind of critical value, and then here on the basis of information, sample informations, your Z calculated is coming 4.43, and as a result, so it is actually overtaking the critical value, and the straightforward decision is to reject the true null hypothesis, because 4.43 is greater than to 1.645. So, this is actually similar kind of examples. So, another examples here, same population proportions. So, we are fixing actually population structure 0.17 against p greater than 0.17. So, that means straightforward a right tail test, and then we are here to specify actually whether calculate test statistic will overtake to Z criticals, and accordingly then here it is coming 2.44, and again you are in a position to reject true null hypothesis. So, likewise, and there is another kind of structure called as hypothesis testing for sigma squares. So, that means actually we have discussed the kind of inferential analytics with the help of Z statistics, then T statistic, and the kind of sample proportion, and then population proportions. And here there is another kind of structure through which you have to analyze the problem with chi-square distributions. And in fact, we have discussed two different test, means 4 different test statistics, Z distribution, T distribution, chi-square distribution, F and F distributions. Out of all these 4 distributions, and usually chi-square and F are positively skewed distributions, and Z and T can be positive, can be negative, but the test procedure is almost all same. Every time you have to specify the null hypothesis and the alternative hypothesis, and then you specify the type 1 error, and then on the basis of degree of freedom and alpha value, that is the type 1 fixation. So, you will find out the critical value, and then on the basis of sample information you have to calculate the sample statistic, and then check whether your sample statistic will be within the critical intervals, or going beyond the critical interval. So, then accordingly you have to take the decisions. The usual standard structure is if your the sample statistic is overtaking the critical value in the lower side and upper sides, then you are in a position to reject the true null hypothesis. Otherwise, you have to accept the true null hypothesis. Then the management decision has to be taken into consideration accordingly. So, this is actually standard procedure, and this case in the chi-square it is actually more or less same, and here only thing is the calculation procedure is a little bit different. For instance, so here the chi-square statistic need to be calculated, and again it is a same actually. So, you have to just find out the sample sample variance, and this is actually population variance, and then on the basis of that you have to calculate the chi-square, and that is what actually it is called as calculated chi-square. And then corresponding to the chi-square and alpha value and degree of freedom, you will find the critical value is coming actually 24.9958, and since it is actually the calculated test statistic calculated chi-square is coming actually less than 2 chi-square critical. So, as a result you are not in a position to reject the true null hypothesis. So, this is actually more or less same like Z distribution and T distribution, but still still you have to see how is the problem, and then accordingly you can take the decisions. And there is another kind of structure which is called as type 2 errors. In the first case we whatever problems we have discussed till now, that is with the help of alpha fixations, that is the type comment about the type 1 error, and against the same problems can be discussed with type 2 errors. So, now this is what actually the structure of type 2 error means. So, you are you are going against the kind of type 1 error decisions. So, we have already gone through this particular process. Here we are actually not rejecting the true null hypothesis, you are accepting the false null hypothesis. That is how the particular structure is about. So, this is the standard structure as usual discussion, and here is the kind of comparisons. See here in this case, so we are targeting here only. So, the particular structure is here. This is actually the kind of type 2 error concept, and this is actually type 1 error concept. So, here is the rejected zone, here is the accepted zone, and this is the correct decisions, and in the case of type 2 error, so this is the correct decision and this is the type 2 errors. Actually we have already discussed the table earlier, and on the basis of that actually whether you can target type 1 error and conclude the kind of things, or you can target the type 2 error, you can conclude the particular things, and management decision need to be taken accordingly. Okay, so, this is how the particular process, and then this is another kind of look regarding the type 2 error for means just comparing actually how is the kind of visualization the type 1 error versus type 2 errors, but the real comparisons you can find it here now. So, this is actually means type 1 error is actually indicated by alpha, and in the case of type 2 errors it is indicated by beta. So, now when actually mu value, that is actually population parameter is changing from one point to another, then the power of the test will be actually changing accordingly. So, this is how the beauty of this particular inferential analytics. So, you have lots of options how to take the decisions, and how to comment about the population parameter with the help of sample statistics, and this is actually how the movement about the change of the population parameter with actually probability value. Okay. So, with respect to the kind of beta component and the power of the test. Okay. So, with this actually we like to conclude here, and in the meantime we have already discussed the kind of testing, and that too with the help of Z distribution, T distribution, and chi-square distribution. So, that means with respect to any kind of problems, so how Z test, T test and chi-square test can be applied, and to get some kind of managerial decisions with the kind of given situations. So, that means we have actually plenty of options to investigate the problem, and then come to get some kind of inference, and on the basis of the particular information you can take some kind of management decisions. And we will stop here, and in the next lecture we will discuss details about the confidence interval and more about the other test statistics. Thank you very much. Have a nice time.